There's also another excellent film, Merchants of Doubt, is another really good film, particularly on climate change, by Naomi Oreskes and Eric Conway. And the book is excellent, and the film is worth watching separately to the book because it has additional information in it. So what we've done is we're actually effectively pulling rabbits from hats, because we've said, look, this all looks far too politically challenging, so we can't carry on like, we can't say that, so therefore we have to find some way around this. We have to massage our assumptions to give nice outputs. And what we've done is we've conjured up, and I think it is a fair expression, because we don't have these things, we have conjured up the concept of negative emission technologies at huge scale. And these technologies are going to suck the carbon dioxide out of the atmosphere in the future. And let's give some sort of feel to what that is. We're talking about hundreds of billions of tons of carbon dioxide to be removed from the atmosphere. Now, it's not exactly the same size as the current fossil fuel industry, but it's an industry that would look roughly the same as the fossil fuel industry. So an industry that doesn't exist today, that we don't have technologies for today, we will assume will be applied in the future, or be developed in the future, by the next generation and by their children, to suck our carbon dioxide out of the atmosphere. And to assume that this technology exists in virtually every single scenario that informs government, including the UK's Committee on Climate Change. They use a lot of this in their scenarios. So it sucks the carbon dioxide out through the atmosphere. Notice it's below zero now. Now, one thing you can guarantee, everyone that wrote those reports before will not be here then. And they probably won't be here then either. You know, people that wrote those reports, like me, will either be pushing up the daisies or be retired in Tuscany. So it's interesting that people that write the reports always put in these technologies for the next generation to solve. And it's not just your generation, it's your kids as well. Because these scenarios always assume it goes on into the next century, because we can't be bothered to do anything about this. It's a real indictment of my generation that we're doing this, and we're normalising it in our models, and that the academic community is not prepared to question it. Particularly as academics, and we engage with the younger generations all the time, we should have more concern for their futures, really. The negative emission that dominates, negative emission technology that dominates, is something called BECCS. It's not the only one out there. There are some other sort of more exotic options out there for removing CO2 from the atmosphere, and some of those may have slightly more hope than this one. But this actually dominates all of the models, including the UK's position on this at the moment. And it's the idea that you will grow biomass on very large scales. As the biomass grows, it sucks these carbon dioxide out of the atmosphere through photosynthesis. You harvest it, you put it on ships, you transport it around the world, put it on trains, take it to power stations, burn it in the power stations, capture the carbon dioxide through some other technology as it goes up the chimney, liquefy the carbon dioxide, or almost liquefy it, pump it a long way underground and stuff it somewhere under the earth and keep it there. So effectively what you're doing is the trees and the plants suck the CO2 out, you're burning the trees and plants, and you're burying the CO2. So you're sort of removing the CO2 from the atmosphere. So in a model, you can see how that looks quite attractive. Then you start to play it out. This has never worked at scale. We have no examples of this working at scale anywhere on the planet. And yet it's assumed in virtually every single scenario to work at scale. There are massive technical and economic unknowns. There's a huge efficiency penalty with it. As an engineer, I think this is an embarrassment. If this is the best that we can do in the 21st century, James Watt would turn in his grave if he thought this was what we were achieving 200 years later. This is really grunt technology. And look at the amount of biomass that's required. 1 to 3 times the area of India, you've got to plant up year after year after year to be able to do this. So almost every single level, this is a real problem, and yet it's normalised in virtually every single scenario, including the UK government's policies, which are based on the CCC's advice, Committee on Climate Change advice. Another way to think about this, at the moment we emit, give or take, 40 billion tonnes of CO2, and half of that gets absorbed by the oceans, and half of it, half of it gets absorbed by the oceans and plants together. So about 10 billion tonnes by the plants, 10 billion tonnes by the oceans, and the other 20 billion tonnes just remains in the atmosphere for a long time. And what we're planning with these other BECCS models is that we're going to do something, roughly absorb, maybe half as much, some of them more than that, as the planet normally does now. So it's like we've found a sort of bolt-on planet. This is a technology that doesn't exist, and we're going to assume it absorbs about as much as our current natural systems do today. And to assume that this works all the time is where my concern is. The odd exotic scenario that does this would be fine as an outlier. But when it becomes the norm, you institutionally set almost like a bias for how we view these issues, which I think is part of our delusion that we can easily solve this problem. Because once you remove that assumption, you end up with very different conclusions. So now I've tried to sort of lay out what the backdrop to all of this is. I want to say what would be the role for the UK in delivering on Paris. And this could be the same really for any industrialised country. So only wealthy country, and there's a paper behind this that's hopefully coming out in the next couple of months. It's all about pies in the UK, or bula as they call them in Sweden. This is our carbon pie that we have, and that's the carbon budget if you like, and it could be a bit bigger depending on the science. It's more likely, I think, to be a bit smaller than a bit bigger because there's a lot of feedbacks that we're not really including.
I have a question. I don't really get why we have a fixed amount when you just said that like the oceans and the plants absorb like 20 gigatons each year.
Yeah.
Or is in the calculations is this already?
Yeah.
Is it already considered?
Yeah, in the models they already factor in those feedbacks, so and those absorptions. So we factor in the oceans, we factor in the plants in all the models, the proper climate models. They include those. It's one of the concerns we have. This is why it might get smaller than this. Is that the oceans may not and the plants may not go on absorbing carbon dioxide.
Mm-hmm.
There's a strong belief that at some point they start to saturate, and there's a whole suite of reasons as to why that might happen. So it could be, one of the major feedbacks could be that we start to have more of the carbon dioxide we emit stays in the atmosphere. And there are some early signs that's starting to happen now. But you also get a fertilizer effect. So for instance, the plants absorb more as the carbon dioxide goes up because it acts as a fertilizer. Now that works up to a point, like all fertilizers work up to a point, then you saturate and it doesn't work anymore. So those numbers, those absorption figures are taken into account in all the numbers and the maths behind this. Is that clear?
Yeah, but I still don't get why you can speak of a total, like it says total carbon dioxide that can be emitted, although we don't know like if there ought to be like a total amount. I mean, it's clear that we should reduce it, but it's hard to see like if it should like be to net zero, like no emission at all, or is it zero including the what is absorbed by plants?
The plants and atmosphere won't go on absorbing the extra CO2 all the time. So we have to go to absolutely zero CO2 because some of the CO2 will always build up in the atmosphere. And because it basically lasts there almost forever, then any CO2 you put up means you're going to increase the temperature. This is different for methane, I hasten to add, but for CO2. So the CO2, every time we emit some CO2, it stays in the atmosphere and increases the temperature. Some of it is absorbed, but the rest of it stays there. And so we know if we want the temperature to hold stable, we've got to stop all carbon dioxide emissions. All of them, particularly from energy, but even from other ones. So we have to make sure we stop all the emissions from the energy system. And what we know is that even when we take account of all of these emissions that are absorbed by the plants and the oceans, the total amount we can emit is about 650 billion tonnes. So it's a pretty, it's rough, but it's good enough for us to know. Now it could be that it could be less than that if these feedbacks, if the oceans stop absorbing like they are now, then it could be less than that. That would be a problem. But at the moment, in that our science says that we should be okay in this time frame for them to carry on absorbing. At the moment, I mean, there's
just wondering, but for example, like humans are breathing, and like 2 gigatons per year are just from humans breathing.
Yeah, but that's part of a natural cycle, that process. So there'll be, we'll be taking it in from one place and putting it out in another. So I wouldn't worry too much. I mean, obviously we breathe out carbon dioxide, and we metabolize the materials that bring this about, and that happens to other animals as well. So there are some concerns of that, but that's part of a natural process, a natural cycle. So that wouldn't be an issue, it'd be in balance. If we weren't pumping out, I mean, basically what we're doing here, we're taking all the trees of the history and burning them almost overnight. That's what we're doing. So it's still part of a natural cycle if you think of it like that. They're still trees or material, but we're just burning them overnight. So we are pretty certain that what this looks like. So it could be a bit bigger, it could be a bit smaller. The chances are it will be smaller. And some people suggest it could be quite a bit smaller, so it could be much more difficult. But the question we then have to ask ourselves is how do we divide that amongst every country in the world? And that is hugely challenging. So, you can imagine if you ask countries, the UK, I'll say, well, we want a slightly bigger slice because we're the UK. I mean, we're a special place. The Americans will want more, the Chinese will want more. Every country's going to want more than they should really have. And so that is a big issue about how you divide this up amongst all countries of the world. So, the argument I often make is perhaps if every country represented another country, we might do it fairer. So if the UK represented the US and the US represented Nigeria, Nigeria represented China, there's some arguments in sort of game theory that everyone will actually play out a much fairer way of splitting the cake. But of course we're not prepared to do that. We send our negotiators out there, we tell the negotiators before they leave, try and get as much as you can. And so you end up with a failed system. But we will have to solve that, otherwise we're going to carry on failing. So the question we've asked in this recent paper is what's a fair slice for the richer countries of the world? This is not to scale, it's just I have to find a pie with a slice out of it. So we're asked what's the richer parts of the world, which I'm just using the OECD here as a catch-all for that. It's not actually the OECD, it's a slightly different mix of countries. But we've looked at the richer parts and we say, well, in dividing the cake, how do you divide it? Divide it on population, historical emissions, your current emissions, your size of your economy. So there's a whole suite of ways you could divide the cake up. And we've used a range of these and have some sort of views as to which ones are more appropriate and which ones are less appropriate. And we've come up with a size for the richer parts of the world. And there's a range of the size of that pie. And then we've asked of this pie, how much did the UK get of that pie? And so we can then do some work then saying, again, do you base it on the population? What do you base it on? So there's a number of factors you use that. We've also done this down to Manchester now, so we've done ones for Manchester City Council, for Greater Manchester, with a number of other parts of the UK, including Scotland. We've got, I think, half of the regional governments in Sweden now have carbon budgets that we've been developing for them. So they've got a budget they can work to. You can also do it by sector as well, so there are different ways to split it up. But the smaller you split it up, the more difficult it gets because the boundaries become a real issue as to quite where does the boundary stop between geographies or between sectors. Nevertheless, you get some idea of it. So for the UK, our figures are between 3 and 3.8 billion tonnes of carbon dioxide is what we can emit from the UK. Across the century from January the 1st, 2020. That's 9 years of current emissions. This does include aviation shipping, but it doesn't include imports and exports. So about 9 years of current emissions. And it's about 8 years for Sweden. So it's, most of the wealthy parts of the world, it's well under a decade that we have of current emissions before we blow the budget. To give a feeling of what that's like in terms of reducing emissions year on year, and that's what's really important, I think, for policymakers, it's somewhere around 10 to 13% every single year. Again, that's pretty much the same across most of the wealthy parts of the world. It's over 10%. I wouldn't be too much worried about the precision of this, but if you can get to that sort of rate of change, then that's what we're looking at. And to give another feel for that, that's about a 70 to 80% reduction by 2030, and something like fully decarbonised energy by 2035 to 2050. That's everything. Planes, trains, ships, industry, everything for energy. And I'm not talking today about agriculture, but agriculture is an enormously important part of the picture. It's probably 20% or so of the warming and the emissions in one way or another, depending on how you measure them, comes from agriculture. We can make those smaller, but we cannot eliminate them. You will always get methane emissions and NO emissions. Whatever you do, if the whole world went vegan, no rice diets, then we'd still have quite a lot of emissions, probably 4 to 6 billion tonnes of carbon dioxide equivalent. And that's one of the reasons we have to have some sort of ways of sequestering some warming gases to compensate for the fact that agriculture will mean you always have some warming. But it's also the reason you need zero carbon energy, because it's a sector you can eliminate all the energy from, but you can't do it from agriculture. So that's why I'm saying here it's zero carbon. But look at that there. And that also plays out to something like 30% in the next 3 years. Can you imagine our own lives and reducing them by 30% in 3 years? This is immediate and profound system change, which is completely different to all those other reports I've shown before, which are basically greening business as usual. But it's the same maths, it's the same science. The only thing I'm missing here is, that's different between this and theirs, is the concept of equity, and I don't use negative emission technologies. That's the only two things. And if you think we shouldn't use equity, and if you think we should rely on future generations, then you come to a different conclusion. So, question then asking, actually, are there any signs of deep change? And I think this is something I wrote a few years ago after coming back from one of the big international negotiations in Germany. And I was thinking about this on the train. It was really depressing on the way back to Sweden. I thought, well, across the realm, where it's politicians, journalists, civil society, academics, the whole lot, we're all going to hell in a handcart. At every single level, we're deluding ourselves, with the odd exception here and there. And so, what I wanted to think about was, is actually that just so depressing? I might as well pack up and go and enjoy myself for the rest of my life. Because there's nothing we can do. And I don't think that's true. I thought I'd think about it, and there is a question here, and am I just trying to dig out areas of hope, unsubstantiated areas of hope? And I don't think so, but it is a question I have to continue to reflect on. So I would argue there's a crack in everything, going back to Leonard Cohen's lyrics. And the crack here, there are plenty of cracks in the sort of real fundamentally established fabric around us. And we forget about these cracks, I think, quite often. I mean, the banking crisis was a huge gaping void in the structures that we had. We didn't know it was going to happen. Very few people thought it was going to happen, at least when it did. And then our response was really interesting. If you went back to 2006 and it said, we want the UK Chancellor of the Exchequer to write a cheque for £500 billion for next year, you think, you're joking, like, you would have been probably taken away by people in white coats. The following year, he was writing a cheque for £500 billion, or thereabouts. And so we used quantitative easing. We pumped money back into the economy. In fact, what we really did, we took money from the public sector and handed it to the private sector again. But what I'm saying here is not that that's a good or a bad thing. You can make your own judgments on that. What I am saying is that we could do things we could never have envisaged before. And we could do that again. You can imagine putting that money into the greening of the infrastructure. If you put that money into greening the UK PLC, we would live in a different country by now. It would look fundamentally different from an infrastructure point of view in that 10 years in between. Social media. Go back to 2005 or 2000 and you couldn't comprehend what social media was. Even way back to 2010, I think we're really struggling to imagine that social media would be like it is today. You know, Obama and Trump were reliant on social media. And to some extent Corbyn has been in the last election. So it's really important, and I'm not saying it's a good or a bad thing. My personal view, and I've had quite a few debates with journalists about this, overall I much prefer it to what we had before. There are massive problems with social media. But before, the media was broadly owned by a handful of rich white men that lived in the countryside. And that's what we've been reading for the last 100 years. And we've completely normalised the news that they give us. And that's how we see in the world, because only a small group of people have controlled the information we have access to. And now what we have is 60 million people madly tweeting in Britain. And given the choice between the two, I'd rather have 60 million nutters tweeting than 4 people owning newspapers. It does require us as users of the media to be discerning, to actually engage with it. So it's not, there are lots and lots of problems with it. It allows fake news to occur. Fake news occurred before, we just didn't know it. Now it's a bit more obvious. So social media, Brexit and Trump, who would have guessed those things? Go back 6, 7 years ago, would anyone think that, the UK would be pulling out of the EU? Virtually no one would have thought that. Who would have thought that someone like Trump would become the leader in the US? Or that someone like Sanders would stand up and say, I'm a socialist and not get shot? So, the Arab Spring, and these are, again, something that no one could envisage, probably driven partly by social media, and all the other things that are there, or facilitated by social media. The plummeting price of renewables. Virtually no one, even in the renewables industry, thought they'd come down in the price they are coming down at. And they're still coming down. They've not yet bottomed out, nothing like it yet. Even offshore wind, which we thought had brought to matured, is now coming down again. So these prices are coming down. That's changing already the investment patterns in energy. And then an organisation like the IMF, which is not really a radical left-wing think tank, the IMF, and yet it's pulling out and saying how important things like the health impacts of fossil fuels are. So they're doing some really interesting work, sort of identifying the problems with fossil fuels, the subsidies involved with them, implicit subsidies in fossil fuels. So I think there are lots of cracks in the fabric. None of those cracks are yet at a full system level, but they are really fairly significant. That's just an example of some of them. There'll be other ones you can think about. And it's through these cracks, I think, that sort of emerge, and it is important, that word, emerge. I don't think they're predicted. They just come out in a way that we couldn't really assess or predict. Bits of light, shards of light. And those shards of light aren't going to solve the problem, but they can be catalysts for changes in debates. So who would have thought 12 months ago that a 15-year-old Swedish schoolgirl, now 16, but 15 then, 15-year-old Swedish schoolgirl would have more of an impact on engagement on climate change than 30 years of NGOs, academics, and all the rest of them? Would anyone think that was reasonable? If you went back 2 years, again, you'd think you were off your rocker if you suggested that. And yet, look at the voice that she has had, and she's not going to solve the problems, and she's the first to admit that. I mean, she's a catalyst for change, and there's certain attributes that she has that allows her this sort of robust and honesty that virtually the rest of us really struggle with. The school strikes, and these aren't just happening in Western Europe. Okay, that's mostly where they're occurring in the US, but they are happening in other parts of the world as well. There have been quite a few of these across some of the countries in the continent of Africa. Extinction Rebellion. Whatever you may think of these things, what's interesting how they are changing the tone of the debate. Extinction Rebellion come up and say we need 2025 for zero carbon. Don't know how you would achieve it, but by doing that, they're already forcing a lot of other people, including the academic community, to start to think, well, how do you bring the date forward? It's not being brought forward by a lot of academics doing work. It's being brought forward by Extinction Rebellion blocking the streets and making claims that aren't always fully substantiated. Having said that, I think the 2025 date that they've chosen is much more in line with a 1.5 degrees centigrade of warming than comes out of most of the science. So I think, most of the scientists say, the science for 1.5 degrees centigrade is broadly in line with what they're saying. what the scientists are saying collectively about, 2030, 2040, 2050 will be all right, is not really substantiated by their own science, unless you believe in negative emission technologies. So in some respects, Extinction Rebellion, I think, are being the more honest broker of what the science itself suggests. I'm not saying they've got that position from the science, but they happen to have coalesced. Flying shame or flying conscience, I think, is probably a nicer way to see that, depending on how you interpret it from Swedish, to make us reflect on that. Who would have thought that would be viable a few years ago? So there's a whole swathe of these shards of light. There are not enough of them and not going to solve the problem, but I think they are interesting to observe, particularly the last 18 months, which from someone who's worked on climate change and really just each year gets worse and worse and worse. Actually, the last year and a half, at least that downward spiral of what it feels like to work on climate change, at least it's stabilised. I think it's probably picking up a little bit. Not a lot, I don't overplay it, but I feel more hopeful or less miserable, that is more accurate than before. So what does this imply for the scale of the action that we need to have? There's only one equation here in this slideshow. Paris plus IPCC equals equity. Now, whether we think equity is right or wrong, it's not on there, but whether we think equity is right or wrong, from a moral point of view, it just comes out of the maths. So really, I don't really care whether people say, oh, well, it's not a political statement, it's just a math statement. You can make the argument for moral reasons and political reasons, and I think they can make very good arguments for moral and political reasons, but if you happen to be a Milton Friedman or take a very right-wing view on these things, a different view of equity like Nozick or something, then you might say, I don't like that from a moral point of view. Well, okay, it's the maths. I'll try and show you why that is. There's sort of a curve you probably have seen before. Now it's become quite popular now. It's an infographic produced by Oxfam, but actually it comes out of the Chancellor and Piketty report in 2015. Lucas Chancellor and Thomas Piketty, a really worthwhile report to look at. And a lot more work has been done that substantiates this sort of framing. Basically, it says that most emissions come from a very small percentage of the population, and not these people down here. So when you think about that, it doesn't matter how much carbon dioxide you squeeze out of this group, you're not going to get much of a saving, because they don't emit. And actually, you can't squeeze it out of most of these people, because they're structurally locked into the system. So this lot have almost no agency, or very little agency about their emissions. But this lot do. They pretend not to. It's essential to take a first-class flight to some climate change conference, in their view. But in reality, of course, they could change their views or their approaches. 50% of global carbon dioxide comes from 10% of the population, there or thereabouts. 70% of the population, 70% of emissions from 20% of the population. Now, that will change from country to country, but the UK is a highly unequal country, so that shape of glass, hourglass, would probably fit quite well for the UK. In Sweden, it would be more straight-sided. It's all come down, but it would be more straight-sided. The US would be similar shape to that. We're trying to get some funding to actually go and sort of plot this for country after country, because we think it'd be quite interesting to see them, because I think it changes your policy framing depending on the shape of those curves, if you like. Does this really matter? Because that's a question you often get asked. Well, does it really matter? There's only a few people that are wealthy. Obviously, from that curve, it matters. But play out the numbers. Imagine we actually thought climate change was an existential problem, that we actually believed it